Hello, class. Thank you all for coming today. Today we are going to be looking further into exponents that we talked about at the end of class yesterday. So let's get to it. So what are exponents? Can we kind of try and remember what exponents were, what they were doing, what they were like? So the way we talked about it yesterday was that in the same way when we learned about multiplication, it was like doing addition over and over and over again. You repeat it. So for example, 6 times 5 in multiplication can also be represented by repeated addition. 6 plus 6 plus 6 plus 6 plus 6, 5 times. And so in that same way, we can use that to help us understand exponents, because exponents are repeated multiplication. They are multiplying something again and again and again repeatedly, just like how multiplication was repeating addition again and again and again. For example, if we have 7 to the power of 4, that's equivalent to saying 7 times 7 times 7 times 7 4 times. Repeated multiplication. So we're gonna try some couple example problems here. So for our first one here, just to get our memory jogging on multiplication, right? 6 times 4, we add up 6 4 times. 6 to the power of 4 means we multiply 6 4 times. Right, the same idea of that repeated um, operation, that repeated task over and over and over, however many times the thing asks for. 7 times 3, we add up 7 3 times, 7 plus 7 plus 7, and 7 to the power of 3, we multiply 7 3 times. 7 times 7 times 7. So they're similar, but where multiplication asks us to add multiple times, power sign asks us to multiply multiple times. But what about if I tried to multiply two exponents together? For an example, what if I tried to multiply 3 to the power of 2 by 3 to the power of 4? How can I make this simpler for myself? Is there any way, these things look similar, is there any way to combine them? Well, let's see what we can't do. Well, if we think about exponents like repeated multiplication, then it's totally fine to write them out this long way, where now 3 to the power of 2 becomes 3 times 3, 2 times. And 3 to the power of 4 becomes 3 times 3 times 3 times 3, 4 times. And so now we put it all into a format we can maybe combine together more easily. So now, well, those parentheses don't matter. We're just multiplying. So now we have a bunch of 3's multiplied by each other. It looks like there's 6 3's. But what is repeated multiplication like we have here? That's the same as taking a power of how many times you're multiplying with it. We're multiplying 3 by itself 6 times. So that is equivalent to 3 to the power of 6. Now let's look at our simple product here. We had 3 to the power of 2 times 3 to the power of 4. We found that that was equal to 3 to the power of 6. We see any pattern here, maybe, between those exponents at the beginning and that new exponent at the end. Long story short, when we can just add those exponents together to get the new exponent when we're multiplying two things with the same base. So because both of these had a base number of 3, when we multiplied them, we found that the new exponent is just going to be the first exponent plus the second exponent. 2 plus 4 gets us the last one, 6. So for some example problems here, ooh, or not. Okay, we'll get to it. Multiply them. But what about if those bases aren't the same, right? What if, uh, for example, one of the bases is 3 and the other one is 2? How can we make this thing a little simpler? Well, we can do that same strategy we started with last time of rewriting these exponents as repeated multiplication, because that's what they are. And so now we have 3 times 3 times 3 times 3, 4 times 2 times 2 times 2 times 2 times 2, that's 5 times. Well, we can take away the parentheses, move them around however we want because it's just multiplication. It's all the same operation. And if I redistribute stuff, it looks like I had a pretty close number of each of the 3's and the 2's. So maybe I can factor some out by pairing up 3 from one and 2 from the other. And so now if I rearrange that stuff, I see, well, it's also equal to 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2, all times 2 because there's one extra 2 left over. I'm just moving stuff around here. But each of those 3 times 2's in the parentheses becomes a 6 now. So now it's 6 times 6 times 6 times 6, 4 times, all times 2. Well, that repeated 6 multiplication we can rewrite as 6 to the power of 4. All that still times 2. So what is the pattern here? We started with 3 to the 4 times 2 to the 5. That was all equal to 2 times 6 to the 4. What patterns can we see here? Well, so with different bases here, right, we split up those first two numbers and we made pairs of as many as we could to get a new common base to use, right? 6. What I worked was each of those little parentheses bases here. Each had the same product in it. That was first base times the second base to get us the third base. Um, and so too long didn't watch. It looks like we can multiply different bases uh, if they have the same exponent here. We had to pull out a 2 here so that it would be 3 to the 4th and then 2 to the 4th. Then one last stop with addition. It's the same idea of we can pull out some common factor of however many of a base uh, the smaller one has. Yeah, we can just factor as much of it as possible. We could factor out 3 to the 4, and then maybe just 1 plus 3 to the 2. And that is all I have time for today. Thank you, everybody, for watching. And please respond to the exit ticket that is on the Google site. Thank you very much.